So we are looking at a typical excess question over here. Let's read the question carefully. A group of learners want to determine the concentration. So this is what you are focusing on. Is sodium hydroxide an acid or a base? Base. They decide to perform a titration using a standard solution of 0.1 mole. So I'm going to do it in a different color because that's a clue. To get an idea of where the end point is, they performed a trial run. Then they added, in the trial run, 27 centimeter cubed or milliliters of sulfuric acid to 20 centimeters, which is 20 moles of the sodium hydroxide. But they passed the endpoint and they found that there was a pH of 3.32. Now that's very significant. This means that after the titration, this is an acidic pH, which means you have an excess of, so this means that there's an excess of hydronium. Beautiful. And then we have a balanced equation. Calculate the concentration of sodium hydroxide that they used in the trial run. The first thing you have to do is convert the pH of 3.32 into a concentration of H3O plus. And you can say that that's going to be equal to 10 to the power of minus 3.32. Okay. That gives us 4,7863 times 10 to the minus 4 moles per dm cubed. We have to decide what we're going to do with that number. So once you have the concentration of H3O plus, you're going to use it to get the moles of H3O plus. And then you're going to use the moles of H3O plus to get the moles of sulfuric acid. This will give us, because this is in excess, this is also going to be the moles of the acid in excess. Why is that important? Because we have the equation that your total moles is equal to N reacted plus what? Okay, great. And so once we have in excess, we'll be able to tick that off. Once we have in total, we actually can get this from the question, the information in the question. Then we can use these two to actually get the missing answer here. And what are we going to do with that answer? We're going to plug it into our balanced formula, because that is going to be in H2SO4 plus 2 NaOH gives you H2SO4 plus H2O. And then once you get the moles that reacted here, and from here you will use the mole ratio to get the moles of NaOH, and that will give you the concentration of NaOH. Let's just look at the overall plan. You start with pH. You use pH to get, you're going to start with pH, and you use pH to get the concentration of H3O plus. Once you have that, you can use an equation to get the moles. And then from the moles of the hydronium, you can get the moles of the acid in excess. And so now that you have the moles of the acid in excess, you can plug it into this formula. This moles total, remember this is the equation, that's your master equation. And when you have an excess reaction, you are always trying to fill in 2 out of these 3 numbers, right? So sometimes they will give you this and that, and you must calculate that. This is like the original, right? Sometimes they will ask you what's in excess. So in any excess question, your aim is to fill in 2 out of these 3 numbers. So what happened is, we were able to do this just from the information in the question. We're able to calculate this from the pH. And now the left, there's only one variable here, N reacted. And so that is how we can find the missing link there. From N reacted, what did it react with? it reacted with NaOH. Okay, and then from the mole ratio, because it reacted with NaOH, we can find the concentration. So let's do that now. From the question, you can see that they give you the concentration of sulfuric acid and the volume of sulfuric acid before the titration starts. So in other words, this information is going to give us in total. Another way of saying in total is in initial. Okay, so that's N equals CV, which is equal to 0.1 times 27 times 10 to the minus 3, which gives me 2.7 times 10 to the minus 3 moles of H2SO4. Now this moles is my in total or in initial. So now if you look at the formula, we have that number. We have 2.7 times 10 to the minus 3. And that is equal to N reacted plus N excess. To calculate N excess, we're going to start back with our concentration of H3O plus. So now that we have the concentration of H3O plus, we must try to get the moles of H3O plus. And we're going to say N equals CV, which is equal to 4,7863 times 10 to the minus 4, multiplied by, we're going to use the volume of the acid and base mixture. They added 27 moles and 20 moles. And after they mixed it together, there was this that was available. So can you see why we have to use the volume of both of these? We have to add it together because that's the total volume of the solution. Because they mixed these two together, they titrated it. So now they are together in one flask. And in that mixture of the whole flask, the whole volume, there is that amount of, there's this amount of the hydronium ions. So that's why to get the moles of that, we have to use the volume of the whole flask at the end, because this is excess. So that volume is going to be 20. So that volume will be 47 times 10 to the minus 3. Okay, what's this answer? That gives you an answer of 2.249, which I'm just going to turn into 2.25 times 10 to the minus 5 moles of H3O plus. Now this is the excess moles. Okay, so that's the excess moles of the H plus ions. Now we don't want the moles of the ions. We want the moles of the acid because that's who we're working with. So we have to look at this ratio. H3O plus to N H2SO4, and this is going to be this ratio of 2:1. Because what type of acid is H2SO4? Because what type of acid is H2SO4? Good. That means that for every one H2SO4 molecule, you're going to have two H3O plus molecules. So you've got the moles of H3O plus, and now you're going to use it to get the moles of the sulfuric acid by dividing by 2. Okay, so I'm going to put this. Oh my God. So you have the moles of H3O plus, and then how many moles of H2SO4 will that be? You're going to have to divide by 2. And that means the moles of the acid is 1,125 times 10 to the minus 5. So what did we actually do? We got the pH value. We converted it into H3O plus concentration. Then from the H3O plus concentration, we got the H3O plus moles. From the H3O plus moles, because the ratio is 2 to 1, we got the moles of the sulfuric acid. This is the leftover stuff. So when we are going back to our equation here, we can now add that number in, which was 1,125 times 10 to the minus 5. And so now we have 2 out of the 3 numbers, and we can easily get in reacted. That gives us 2,689 times 10 to the minus 3 moles of H2SO4. So that now we have the moles reacted. Where does it go? It goes into the reaction because it was the one that was reacted. And so we have the amount of moles that's involved in this reaction is 2.68 times 10 to the minus 3 moles. Now to get from the moles of acid to the moles of NaOH, I'm going to use my ratio. What's my ratio? Yeah, so we're going to use the ratio 1 over half. So we want the NaOH, so we're going to use it 2 over 1. That's my mole ratio. So we're going to multiply that together to get 5.3775 times 10 to the minus 3 moles. And then we're going to try to get to the concentration of that by using C equals N over V, which is 5.3775 times 10 to the minus 3. What is the volume of the hydroxide? Over 20 times 10 to the minus 3. And that gives us the answer of 0.2689 moles per dm3. Thank you for watching.